Hi guys, good morning. Can you hear me? Hello. Yes, guys, good morning. Can you hear me? Yeah. So let us start session. Yes, last class. Yes, about that introduction discussed. Okay, what is system software? What is application software? Next, what is OS? About OS discussed. Next, application software, front end, back end. This thing discussed here. Next, yes, language and packages. Next, about languages discussed here. About languages, like let's about generation of computers discussed. Yes, next about low level languages and high level language discussed here. Low level, high level discussed. Okay. Yes, compilers and interpreters are used to convert from high level language to, yes, compilers, interpreters. Yes, compilers and interpreters. Okay. Yes, compilers, interpreters are to convert from high level language to binary codes. Okay, so compilers and interpreters are to convert from high level language to binary codes. High level language to binary codes. So compilers and interpreters are to convert from high level language to binary codes. High level language to binary codes. High level language to binary codes. Yes, what is compiler and what is interpreter? Yes, today topic is about compiler versus interpreter. Yes, compiler versus interpreter. So what is compiler? What is interpreter? Yes, let us see about compiler and interpreter. Yes, about compiler and interpreter. So what is compiler? What is interpreter? So compiler versus interpreter. Here. Okay. Let us see. Yes. So compiler and interpreter. First, let us see about interpreter here. Let us see about interpreter. So about interpreter. First interpreter, I'm taking Python. Python to explain about interpreter, I'm taking Python. Suppose test.py, it's a Python script. Okay, for interpreter, I'm taking Python script. Just for interpreter, I'm taking Python script here. See, Python script. Just using Notepad, I'm developing Python script here. See, actually here Python, for Python, yes, we have the PyCharm ID actually. Yes, in projects you'll be using PyCharm ID, but here it is small program, so PyCharm ID is not necessary. Yes, let us go with Notepad. Yes, we'll write one simple script using Notepad. D drive, suppose some test folder. Here D drive test folder. Now at the command prompt. Yes, at the command prompt, go to test folder, D drive test folder. Okay, D colon, that will take to D drive. D colon, that will take to D drive folder. DER. Okay. See, test folder, test. It is test directory. CD command, change of directory. CD command to change the CD test changed. Okay, now here let's take Notepad. Yes, Notepad. Support test.py. Cannot find. Yes, do you want to create new file? Yes. A is equal to 10. Yes, B is equal to 20. C is equal to A plus B. A equal to B equal to C equal to A plus B. Adding two numbers. Print. Yes, addition. Print addition is equal to addition equal to C displaying C value. C equal to A plus B displaying C value. Okay, next A minus B and A into B. C equal to A minus B. Yes. Addition. Next subtraction. Subtraction. Subtraction equal to. Okay, next C equal to A into B. Yes. Next multiplication. A into B. Multiplication. Yes. Multiplication equal to. Multiplication equal to. Yes. Multiplication equal to. Yeah, this simple script. Python simple script. Just Python simple script. Just Python simple script. Okay, A equal 10, B equal 20, C equal to A plus B, addition value, subtraction, and multiplication. That is save, and closing this is yes. Now here, DR, see, test.py, that Python script. Python script, just simply running the script Python, yes, test.py, yes, addition, subtraction, multiplication. Addition, subtraction, and multiplication. Right. So addition 30, subtraction minus 10, multiplication 200. That's it. Addition, subtraction, and multiplication. Okay. So this is Python scripted. Okay. Yes. So how this interpreter is working? How interpreter is working? Let us say about interpreter. Interpreter. How Python is interpreter based language. Python is interpreter based language. Okay. Here we are submitting like this. So this is Python interpreter. Yes, it's a Python interpreter executing Python script. Python interpreter executing Python script. It's an interpreter executing Python script. Okay. See here Python script is like this. Python script. See, first statement. Here, first statement. A equal to 10, right? First statement. Yes, B equal to the second statement. Okay, next. B equal to A plus B. Yes, next displaying print addition equal to. Okay, assume that kind of program here. S equal to A minus B, subtraction. Yes, print subtraction. Okay, right? C equal to A into B, multiplication. Print multiplication. So this is Python. Python script. Okay, right? Yes. How it's working here? How interpreter working on script? Interpreter checking first line. Interpreter checks the first line. Interpreter checks the first line. Yes. If first line is correct, then what happens here? If first line is correct, then converts this code into binary code. It converts this code into binary code. Okay. Yes, if first line is correct. If first line is correct, checking first statements. Checking first statements. Yes, if it is correct, simply converts into binary code. Simply converts into binary code. Interpreter checking first statement. Suppose syntax and everything is fine. Simply converts into binary code. That binary code given to processor. Binary code given to processor. So processor taking binary code, generating output finally. Generating output finally. Okay, right? So you can see next coming statements may be right or wrong. Next coming statements may be right or wrong. So interpreter never think about next coming statements. Interpreter never think about next coming statements. Okay. Yes, if a statement is correct, immediately converts into binary code generating output. Here, we are checking for next statement. Suppose next statement also correct. Next statement also correct. Same happens here. It converts into binary codes. Yes. It converts into binary codes generating outputs. Okay. Yes, it converts into binary code generating output here. Generating outputs. It converts into binary codes generating outputs. Okay. Yes, after that checking for next statements. Checking for next, suppose next statement something wrong. Something wrong, simply stops. Next statement, something wrong, simply stops. Any error comes, interpreter stops. Okay. One second. So you can interpreter checks the first statements. If it is correct, converts into binary codes, generating outputs. Checking for next statement also correct, converts into binary code, generating output. Next statement, something wrong, stops. Something wrong, stops. Okay. So any error comes, stops here. Yeah, tell me. Tell me
Sir,
what's your.
sir, why like what I understood is like while writing the program, interpreter helps to stop breaking. Like I didn't get it properly. While you are saying while writing the program, it interpreters like helps in helping.
No, 1 second. This is the program. So this is program. This program will execute by the interpreter. So interpreter checking the first line. Suppose first line is correct, this executes.
Okay.
Okay. Next line correct, it executes. Next line correct, executes means A plus B calculating, then assign to C. Next line correct, that output getting. Okay. So what happens here? Checking first statement. If first statement is correct, simply that statement interpreter convert the statements into binary code. See, interpreters and compilers both are to convert high level language to binary code. This is high level language code. This is high level language codes. High level language codes. Yes, like A equal to 10, B equal to 20, C equal to A plus B. So interpreter checking first statement. Suppose first statement is correct. Simply converts into binary format. After that, given to processor. Processor executes the statement. So completed statement. Then checking for second statement. Suppose second statement also correct. Second statement also correct. Simply converts in binary format. Second statement also correct. Simply converts in binary format. That binary format given to processor. Now processor generating output here. Processor generating output. Suppose next statement something wrong, simply stops. Yes, interpreter any error comes, it stops here. Even it won't go for next statements. Okay, any error comes, simply stops. Any error, interpreter stops. Any error, interpreter stops. Even it won't check for next statements here. Yes, any error comes, interpreter stops. Let me show same thing here. Yes, see, let us see. First line, next, suppose something wrong here. Here, there is a mistake. Some comma missing. Suppose here bracket missing. Here double quote missing. Totally how many errors? 3 errors. Totally here 3 errors. Totally 3 errors. Totally 3 errors. Totally 3 errors here. Okay, now run it. Run it. Yes. See this. It's showing only first error, right? Next error is not displaying here. Displaying only one error. Only one error here. Because any error comes, interpreter stops. Any error comes, interpreter stops. Any error comes, interpreter stops. Okay, now correct this mistake here. Correct this 8th line error. Yes, saying that 8th line, yes, error correction is done. After correction, yes, now run it here. Now it will show the next error, another error. Next, so that means interpreter any error comes simply stops here. Any error comes simply stops. Any error simply stops. Any error simply stops. Any error simply stops here. Okay, right? Yes, now let us correct this error. Yes, save it, exit. Yes, now again, now run it here. Again run it. Yes, next error. That means at a time showing only one error. It's not showing all the errors. It is not showing all the errors. Only one error. Only one error. No correction of this mistake. Okay, right? Correction of this mistake. Save. So here only one error is showing. It's showing only one error. Only one error is showing here. Only one error. Right? So this is working of interpreter. Yes. How interpreter working here? Line by line. First line checking if it is correct, then executing. Second line correct, then executing. Third line something wrong, simply stops. Third line something wrong, simply stops. So this is working of interpreter. Okay, fine. Yes, next about compile. Yes, 1 second. Just a minute. Some guy is asking, some student is asking for something. One second. Just a minute. Yeah, this is already WhatsApp created. Group created. Let me show that group. Yeah, this is Yes, you're asking for how to contact. Here, this is my WhatsApp. Yes, you can contact here. This WhatsApp number. You can take 1718123. Okay, please share your information and add to group. Your name. Yes, next one. WhatsApp post here. Next one. What's your time? Time and your Gmail ID. I need this one. I'll add to group. This is your group. Create it. Yes. Yes, this is group created. In this group, see yesterday's session shared already. Session 3 shared. Recording also shared. Document shared. Session 2 document recording shared. Okay, session 1 and recording document. So everything sharing in the group. Okay. Yes, today I'll give the drive access. Today by the afternoon I'll give the drive access here. Now presently follow the group here. Okay. Today afternoon I'll give the drive access. Today afternoon I'll give the drive access. So this is. Please take this number. You're asking for this number, right? Just take this number. Please share your details and add to group. Okay, I think they've taken everyone. Okay, fine. Let us continue our session. Yeah. So this is checking first line. Yes, if it is correct, then executing. Next, checking next line correct, then executing. Something wrong here, stops. Something wrong, stops. This is working of interpreter. Next, compiler. How compiler is working? Let us say about compiler. Yes, how compiler is working? Yes, about compiler. See about compiler. How compiler is working? See about compiler. Yes, about compiler. See, for compiler, I'm taking C language. For compiler, I'm taking C language. C program. Let us take some C program for compiler. To understand C compiler, support start C program. Yes, how it's working. Yes, compiler. Yes, C language. For compiler, I'm taking C language. Example. Yeah, this is C program. Program to add, subtract, multiply two numbers. Same as that Python scripting, C language. Add, subtract, and multiply two numbers. Here this is a main function. Yes, ABC variable, 3 variables. Yes, enter first number, enter second number. Yes, next after reading two numbers, C equal to A plus B, A minus B, A into B. So this is C program. Compile success, no errors, and running. First number 10, second number 20. Okay, addition 30, subtraction minus 10, multiplication 200. Fine. Yes, how this compile is working, how it's working. Yes, how it's working here. How compile is working. Yes, how compile is working. Let us see. See, compiler checking for the first statement. Yes, compiler also checking for the first statement. Suppose first statement is correct, even correct, it won't convert into binary code. No, it won't convert into binary code. Even statement is correct, it won't convert into binary code. Yes, even the statement is correct, it won't convert into binary code. Okay, next checking for next statement. Suppose next statement is correct, even correct, it won't convert into binary code. Next checking for next state. Suppose something wrong, compiler shows that error at some line. Okay, after that, checking next statement or even error comes, compiler goes to next statement also. Checking the statement. Suppose this is correct, next go to next line. Checking next statement. This also correct, next line. Suppose something wrong here, error at some line here. Yes, after next statement. Like this, compiler checks the whole program from top to bottom. Compiler checks all the lines from top to what shows all the errors. Yes, compiler shows all the errors in the program. Suppose if it's same thing interpreter, what happens here? First statement checking, generating output. Next statement correct, generating output. Next statement something wrong, simply stops. Yes, interpreter shows only one error. Any error comes, simply stops. That I showed practically. Practically we discussed, right? Practically we discussed it. So any error comes, interpreter stops. Any error comes, interpreter stops. But compiler is not like that. Compile is not like that here. Yes, how compile is working here? Compiler checking whole program from top to bottom. It checks complete all lines from top to what shows all the errors. First error, next error, next error. Let us see that. Yes. Suppose same program. Suppose there are some mistakes here, for example. Some mistakes. Suppose here semicolon missing. Suppose here bracket missing. Okay. Suppose here comma missing. Comma missing. Okay. Suppose here semicolon missing. So printer. Suppose here double quotation missing. Okay, some missing statements. Suppose here bracket missing, bracket missing, bracket missing. Okay, right. Yes, what happens here? Now here, suppose let us see here also bracket missing. Fine, save, saved. Now compile, compile it. Yes, errors, 8 errors. That is showing all the errors from top to bottom. So compiler shows all the errors from top to bottom. See that. First error, 16th line error, declaration syntax error. Next 18th line error. Next 22nd line error, 27th line error, 29th line error, 29th line error, 34th line error, 42 error. All the errors from top to bottom. Compiler shows all the errors from top to bottom. Compiler shows all errors from top to bottom. Okay, interpreter is only one error. Interpreter is only one error, but compile is all the errors. Now let us correct mistakes here. Let us correct all the mistakes here. Yes, let us correct all the mistakes here. Semicolon missing here. Here bracket missing. Okay. Yes, here semicolon missing. Okay. Yes, here bracket missing. Yeah. Now file saved here. Yes, overwriting. Now recompile. Yes, still some more errors. Yes, four errors. Four errors. Four errors. No correct. So here comma missing. Comma missing. Next here double quotation missing. Double quotation missing here. Yes, next here bracket missing. Bracket missing, right? No. Save it. Yes. Overwriting. Yes. Compile. Compile success. No errors. No errors. No errors, right? No errors. Program successfully completed. No errors. Program successfully. Yes. Compiled. No errors. Okay. Yes. So correction of mistakes after correction. Yes. Next. Recompile. When you recompile, everything is fine. Here no error. Okay. Here also no error. Suppose here also no error. Top to bottom everything is fine. So compiler checks the whole program from top to bottom. Whatever interpreter only one line checking. Checking first line, then giving output. Checking second line, giving output here. Next line something wrong, simply stops. It shows only one error. Interpreter shows only one error. But compiler shows all the errors from top to bottom. Top to bottom. Yes, interpreter, any error comes, stops. Interpreter, any error comes, interpreter stops here. But compiler, it won't stop. Compiler checks whole program. It checks whole program from top to bottom. It checks whole program. Okay. Yes, compiler. Compiler checks whole program from top to bottom. Okay. It checks whole program from top to compiler checks whole program from top to bottom. Okay. Yes. Compiler checks whole program from top to bottom. Here no errors. If no errors, then what happens here? The whole program from top to bottom. Suppose if no errors, then what happens? If no errors, then what happens? Let me show that practically. Yes. If no errors, then compiler opens another file. Compiler opens another file. Compiler, it opens another file. Compiler opening another file. Yes, if no errors, then compiler opening another file. Okay. Yes, it opens another file. Yes, compiler checks whole program top to bottom. Okay. Yes, if no errors, this whole converts in binary format. Whole code converts in binary format. Zeros ones format. Zeros ones format. Zeros binary format here. Okay. Yes, the source code completely converts in binary format. Completely converts in binary format. Okay. So this code, all this code converts in binary. This code is a this is this codes converts to binary format and write to another file. Here the second file creating, the second file is exe file. This is exe. So test.c converts to test.exe file. Test.exe. Now it's exe file. Okay. So this is test.c file. This test.c file converts to test.exe file. Here exe file. Here that exe file. That exe file given to processor. That exe file given to processor. So processor generating output. Processor generating simply outputs. Processor it generates outputs. It generates outputs. Okay. It generates outputs. Okay. Yes. So what happens here? Compiler checks the whole program from top to bottom. Compiler checks whole codes from top to bottom. Suppose if no errors, generating one exe file. That exe file given to processor, then executes finally. So at a time executing. Okay, this is working of compiler. So compiler checks the all the statements from top to bottom. Top to bottom. Yes, and shows all the errors. If no errors, everything is fine. Generating exe file. That exe file given the processor. So processor generates outputs that here. Okay, so this is what is happening here. Okay, interpreter compile difference. Now tell me guys, what's the difference observed between these two? See, first page explanation, second page explanation. What's the difference you observed here? First page explanation, second page. Yes, just to compare this, I place it side by side. Side by side. Now what you observed? What you observed the difference? So what's exactly difference between interpreter and compiler? Yes, no observation.
Are you asking this question or?
Question.
Okay, so in the interpreter.
What do you observe? What do you observe difference between these two?
So if there is an error in the code, the interpreter right away stops, and in compiler, it will actually go through the entire code, and whatever the errors are there, it put all the errors together and displays it.
Okay, that's okay, fine. Yes, next one more difference observed here. First page, see the first page and second page. See the two pages. What the difference is there in these two pages?
So it converts into .exe file.
Yes, right. Exe file. That's the difference. Compiler, yes, converts that into exe file. Whole code converts in exe format. Compiler generates exe file. Compiler generates exe file. Compiler generates exe file. Okay. Yes. See this. Yes, let us see that the differences exactly. Interpreter versus compiler differences. Yes, interpreter versus compiler. Yes, interpreter versus compiler. Interpreter versus compiler. Statement. Interpreter. It checks the code line by line. Interpreter checks the code line by line. Compiler, yes, it checks the code from top to bottom. It checks the code from top to bottom. Okay, yes. Interpreter checks only one line at a time, but compiler whole code. It checks the code from top to bottom. Next, yes. One second. Yes, when come to output here, it generates outputs line by line. First line checking if it is correct, giving output here. Yes, second line correct, generating outputs. But compile is not like that here. In case of compile, what happens here? Some exe file getting. That exe file executing at a time. So at a time, top to bottom executes at a time. So at a time output here, at a time outputs. So interpret is line by line. So first line checking, then execution. Second line checking, then execution. Third line checking, then execution. But compile is, so compiler checks the code from top to bottom. Compiler checks the, yes, whole code from top to bottom. That whole code from top to bottom. Okay, yes. Then execution, yes, at a time, yes, it generates output. Compiler, yes, compiler based program, yes, creating one exe file, generating output at a time. Yes, it generates output at a time. At a time. It generates output at a time here. So because of exe file, so compiler generating exe file, that exe file executing at a time here. So output is at a time. Okay, right? Next, one more difference. Yes, interpreter shows only one error. Shows only one error. It shows only one error. It shows only one error. Compiler, yes, it shows all the errors from top to bottom, it shows all this from top to bottom. Okay, yes. See, interpreter, it shows only one error. Interpreter shows only one error. Compiler, it shows all the errors from top to bottom. All errors from top to bottom. Okay, interpreter is only one error. See, interpreter, any error comes, stops. Any error, stopping. So only one error. But compiler, it shows all errors from top to bottom. Okay, yes. Next important difference, exe file. Exe file, yes, it does not generate exe file. It does not generate exe file. Yes, compiler, it generates exe file. It generates exe file. Generates exe file. Okay, so interpreter does not generate exe file. Compiler, it generates exe file. Okay, yes. Next here, generates exe. Let me show that exe file also. See, this is your program. Yes, back end of this math.cpp. Name of the program file is math.cpp. Yes, C software, C drive, turbo C. Yes, bin. Yes, C math.cpp. Yes, the backup file. Yes, CPP is math.cpp. So this file. Okay. This is the program. C program, C++ both are same. C++ compiler can be used for both C as well as C++. C++ compiler using for both. Okay. Yes. Now this is CPP. Math.cpp. Now let us compile success, no errors. Now run it. Run this. See, observe back and here. Run it. See, when run it here, see this. 1 second. I'm repeating once again. 10, 20. See, that existing file, that old files. Okay, these files I'm deleting here. Delete and delete. See that math.cpp. See, compile, now run it. See, when you try to run it here, so just observe back and here. When you're running here, observe here, run. See that math. that math application created. Math its application. What is that application? It's exe file. Properties. Go to properties here. .exe rates. .exe file created. .exe file created. I think it's clear, right? It's clear. Okay. Compiler generates exe file. That exe file executes. That's it. Okay. So you get generating exe file. Compiler generating exe file. Compiler generating exe file. Okay, when come to interpreter, Python interpreter. Python is the interpreter based language. Yes, interpreter, what happens here? See, Python, yes, this executes script directly. The source code executes directly. These are the source code here. Yes, source code. Source code executes directly, the source code. This is source code. So interpreter executes source code directly. It executes source code directly. The source code executing directly. Source code executed directly. The source code executed directly. Okay, yes, when come to compiler, what happens here? The source code converts into binary format with exe file. Exe file executes here. So backend exe file created, right? That exe file executed. That exe file executing. Okay, so here compiler, yes, compiler exe file executes. Whereas interpret source code executes directly here. Interpret executes source code directly. Okay, yes, see this. Interpreter does not generate exe file. Compiler it generates exe file. Next interpreter, it executes source code directly. It executes source code directly here. Directly, it executes source code directly here. It executes source code directly. Okay, interpreter executes source code directly here. So compiler, yes, interpreter executes source code directly here. Okay, compiler it executes exe file. It executes exe file. It executes exe file. Okay, see compiler generating exe file and executes that exe file. Yes, interpreter don't have exe file. No exe file here. It executes source code directly. It executes source code direct. So this is difference. Main difference is this. Fourth and fifth point difference. Interpreter does not generate exe. Compiler generates exe. Okay, yes, interpret it executes source code directly. Yes, compiler based exe create that exe file executes. Okay, yes, next other differences. Yes, come interpreter based. These are called as scripting languages. They are called as scripting languages. They are called as scripting languages. Okay, so interpreter based is called as scripting languages. These are called as scripting languages. So compiler based. Here these are called as programming language. Programming language. They are called as programming language. Okay, scripting language, programming language. Okay, so interpreter based is a scripting language. Compiler based is a programming language. So this is scripting language. Interpreter based language called as scripting language. Compiler based calling as programming language. See interpreter based language examples. Python is the best example of interpreter based language. Python. HTML is interpreter based language. PHP is the interpreter based language. Okay, yes, Perl is the interpreter based language. Next, JavaScript is interpreter based language. So these are interpreter based language. For Python script, Python is the interpreter. Python interpreter for the Python script. For HTML, browser. For HTML, browser is a interpreter for the HTML. Okay, PHP scripting, PHP interpreter, Perl interpreters. They are having their own interpreters. For HTML, it's a browser. JavaScript also browser. Okay, HTML and JavaScript browser is an interpreter. Okay, see JavaScript is not a Java. Java is different. JavaScript is different here. So JavaScript using at the client side, Java using at the server side. JavaScript at the client side, Java at the server side. JavaScript is a JavaScript is a browser understandable language. Java is a JVM understandable language. Java is a JVM, Java Virtual Machine. JavaScript is a browser understandable language. Okay, Java is a JVM understandable language. JavaScript different, Java different. Both are not same. Yeah. Okay, one second. Yes, compiler based examples. C, C++, and .NET, C Sharp, compiler based. Okay. Okay. So these are scripting language examples here. Compiler based. The programming language examples here. Yes, scripting based, interpreter based here. Scripting language are interpreter. They are scripting language. Yes, compiler based are called as programming languages. So these are compiler based languages. Yes, here come to some conclusion. Interpreter, compiler, main difference exe file. Interpreter, compiler, main difference for exe file here. So interpreter, yes, interpreter. See, interpreter based language. Interpreter. See, interpreter based language. Interpreter based language. Based language don't have exe file. Don't have exe file. Interpreter based language don't have exe file. Okay. So interpreter based language don't have exe file. There is no exe file for the interpreter based language. Okay. Yes, compiler. Yes, compiler generates exe. So that means everything is in exe file. Everything is in exe format. Exe. Okay. So finally getting exe format. Okay. See, interpreter based language don't have exe file. Interpreter based language don't have exe file. Okay. Yes, in compiler, everything is in exe file. So generating exe file, that exe file executes. JVM is Java Virtual Machine. Yes, we'll discuss. Tomorrow topic about JVM. Tomorrow I'll explain. Okay, tomorrow we'll be discussing about JVM topic. Okay, Java Virtual Machine. Okay, so this is difference. See, interpreter compiler differences. Interpreter, it checks the code. It checks the code line by line. Yes, compiler, it checks whole code from top to bottom at a time, checking here. Yes, interpreter generates output line by line. Compiler generates output at a time output. Okay, yes, interpreter shows only one error. Interpret is only one error, but compiler shows all the errors from top to bottom. See, interpreter does not generate exe. Yes, compiler generates exe. Yes, interpreter executes source code. Compiler executes exe file. Yes, interpreter scripting language. Compiler programming language. Examples. Finally, conclusion. Yes, interpreter based language don't have exe file. See, interpreter based language don't have exe file. Yes, here compiler, here everything is exe file. Difference. Okay, fine. That is my question, Ramya. Yes. Now what is Java? See here, you are getting doubt. I know that. Yeah, this trainer, this MN is talking about many things, but he's not talking of Java. Where is Java?
Yes.
See, explaining about all of these things, many things. So where is Java? Now let us start Java. Yes, what is exactly Java? Okay. Yeah, Java, is it compiler based or interpreter based? Java, is it compiler based or interpreter based? First, let me explain, then you decide it. I'll explain about Java. How Java is working. Okay. How Java is working. I'll explain about Java. You decide it. Is it interpreter based or compiler? Finally, you have to decide it. Okay. So let us start. Yes. See, except Java, in other languages, what happens in other languages? What happens here? Suppose first of all, source code. Yes, source code converts into binary code. Source code converts into binary code. Binary code is given to processor. Okay, processor finally generating output. Okay, suppose C program or C++ Java, except Java in other language, what happens here? Source code converts into binary code. Here this is by the either interpreter or compiler. Yes, interpreter or compiler. Okay, so interpreter or compiler. Okay, so this part source code to binary code by the interpreter or compiler, source code to binary code by the either interpreter or compiler. Suppose C language, compiler converts source code to binary code. Python, interpreter converts source code to binary code. HTML, also interpreter converts source code to binary code. C++, compiler converts source code to binary code. So depends on language here. Yes, maybe interpreter or compiler involving here. Either interpreter or compiler. Only one thing involving here, either interpreter or compiler involving. Okay, either compiler or interpreter. That's it here. Yes, come to Java. Yes, Java, what happens here? Java. So in Java, what happens here? Java, first of all, there is source code. Yes, first of all, source code converts into bytecode. Here there is a bytecode. Java bytecode it is here. This bytecode converts into binary code. This bytecode converts into binary code. Binary code given to processor. Binary code given to processor. Finally generating output. Okay. Yes, here in Java, bytecode it is here. See Java two steps: source code to bytecode, bytecode to binary code. Okay. Except Java in other language, it's only one step. Okay, except Java in other language, only one step. Source to binary codes. Except Java in other language, only one step. Only one step. Only one step. Only one step. But in Java, two steps: source code to bytecode to binary codes. See why bytecode introduced in Java here. Bytecode introduced. Yes, bytecode introduced in Java. Yes, Java. Yes, to make it as independent platform. To make it as independent platform. Yes, independent platform. To make it as independent platform. Okay. So bytecode, yes, was introduced. Bytecode was introduced in Java to make this Java as independent platform. To make it as independent platform. So why bytecode introduced in Java? To make this Java as independent platform. To make Java program as independent platform. To make it as Java. To make it as independent platform. So bytecode main purpose is to make it as independent platform for independent platform. Okay, what is bytecode? We'll discuss next. Okay, next coming topic in Java programming, I'll explain. Java programming, I'll explain about bytecode. Okay, in Java programming, I'll explain about bytecodes. Okay, so what is independent platform? Yes, we'll discuss. Next coming topic, independent platform. Okay, yes, source code to bytecodes. Yes, here source code to bytecode. Yes, in Java source code to byte. Yes, this part where the Java compiler. So Java compiler converts source code to bytecode. Source code to bytecode. Next bytecode to binary code. Bytecode to binary codes. Bytecode to binary. So this part where the Java. Yes, Java interpreter. Java interpreter. Java interpreter. Java interpreter. Okay. Yes, source code to bytecode by the Java compiler, bytecode to binary code by Java interpreter. Yes, let us see one example. Java also. Java program. Here, suppose yes, Notepad. Let us write one Java program. Notepad. See here at this stage, just I'm using Notepad. Actually, Java programs in daily class, it's Eclipse. It's Eclipse sample.java. See, our daily class is Eclipse. Our daily class is Eclipse only here. Okay, just understanding purpose. Now I'm using Notepad here. Our daily topic is Eclipse only. Okay, Notepad never using. In real time, never using Notepads. Even our class also never using Notepads. Always Eclipse. Okay, yes, here Notepad. Okay, for understanding purpose, I'm taking Notepad. Yes, public class sample class name is sample, public class sample, starting ending, sample class starting ending. Yes, here's a system dot, yes, out dot, system dot out dot println, system dot out dot println. Yes, hello world. Okay, so public class sample, system dot out dot public static void main method, string square bracket args, yes, leverage, yes, close main method, save it. See, public class sample is writing simple Java program. So today topic is about Java. Is it compiler based or interpreter based? Our topic is about compilers interpret, not about Java program. Yes, what is public class sample? What is public static void main? This topic next coming topic. Once Java installed, yes, once Java installed, then going for Java programming. That time I will explain what is public, what is static, what is void, what is main. In Java programming, I will explain here. Yes, today topic is about compilers and interpreters. Our topic is about compiler and interpreter. Don't think about Java program. Don't think about Java program. Java programming next day. Okay. Okay. Now public class sample. So this is simple Java program. Yes. How the Java program is working here? Java program. Here. See. Sample.java file. Extract. A text file created. .txt. Okay. Space. Okay. Yeah. 1 second. Save as. Else. Read. Sample folder. Test folder. One second. Just a minute. One thing. L. Here deleted. Yes, notepad. Notepad. Sample dot java file. Because of space dot txt file created. Okay. Notepad sample dot java file. Okay. Public class sample public static void main. So this is simple Java program. Save and exit CLS. Okay. Yes. Now sample.java file 10:30 TM just now created. Now Java C compilation. Now I'm compiling sample.java file compiling. Yes, compiled. So yes, sample.java it's a source code. Sample.java is a source code file. Okay. See notepad. Yeah, this is kind of source Java source code. Java source code. Okay, the source code sample.java given to Java compiler. Java compiler. Now result file. After compilation, result file is dot class file got it. Okay. See here first notepad. So sample.java program developed after developing. Yes, here sample.java. One second del start.class deleted. CLS here. So sample.java file. Now it's compiling Java C. Sample.java compiled. After compile check it. Dot class file. Dot class. Now what's happening here? So first sample.java it's a source code. Sample.java is a source code. It's a source code. Yeah, this source code given to Java C compiler. Okay, sample.java it's a source code. That source code given to Java compiler. Java compiler converts it dot Java into dot class. So dot class file. Sample dot class file. Yes, dot class is byte. It's a byte code. This is byte code, right? Source code to byte code. Okay. So what is happening here? Yes. In Java, what is happening? Errors checking. Error checking with the compiler. Okay, errors checking by the compiler. Error checking by the compiler. Suppose if no errors, what happens here? It generates dot plus. If no errors, it generates dot plus file. Generates dot plus file. It generates dot plus file. Okay. Yes, here don't have error. The dot plus file generated. Okay, fine. See, sample.java, the source code given to Java C compiler. Java C compiler generating dot plus file. Okay. The dot plus file got it. Now this dot plus file executing Java test. Yes, executed. Sorry. Java sample, sorry, not test. Java sample. Java sample. Dot class executed. Hello world, right? Hello world got it. Hello world, right? Yes, here Java C means it's a Java compiler. Java compiler checking for all the errors in .java file. If no errors, generating dot class file. Okay, that means source code sample.java converting to bytecode file dot class file. That's it here. So source code to bytecode, source code to binary. Yes, source code to bytecode. This part. Yes, sample.java source code given to Java C compiler generated dot class means bytecode file. Bytecode, right? Okay. In Java, errors checking by the compiler. If no errors, it generates dot class file. After that, now this dot class file, this dot class file given to Java. What is this Java here? So Java C means is compiler. What is this Java? It's interpreter. This interpreter. This is interpreter. This is compiler. This is Java interpreter. Java interpreter. So dot class file. Sample dot class file given to interpreter. Sample dot class file given to Java interpreter. Now sample dot class file. Sample dot class file. That bytecode file is given to Java interpreter. Java interpreter. Java interpreter. Java interpreter, right? Yes, Java interpreter. Okay. Java interpreter. Okay, that bytecode file given to Java interpreter. Now interpreter taking that bytecode, now it will convert into binary formats. Binary code. Converts in binary code. That binary code is given to processor. So processor generally, the processor finally generating output here. Processor finally generating output. Okay. Source code to bytecode by the Java compiler. So between the Java compiler, source code given to Java compiler, generated bytecode. That bytecode file given to Java interpreter generated bytecode, binary code, and given to processor finally. So in Java, errors checking by the compiler. If no error generates dot class file. Okay. Next, program execution. Yes, program. Java program dot class file. Program dot class file. Yes, executing. Yes, executing by the interpreter. Okay. Interpreter, right? Executing by the interpreter. Okay, right? So what is happening here? Errors checking by the compiler. Error checking by the compiler. By the compiler. Next, execution. Program execution. Program execution. Execution by the interpreter. By the interpreter. That's it. So tell me, Java depends on what? Compiler and interpreter. Tell me, as per this discussion, what you understand here? As per this discussion, what you understand? The Java depends on compiler, interpreter, and both are.
It has both compiler and so Java language has compiler and interpreter.
Yes, come on, guys, others. Yes, Java depends on both compiler as well interpreter. Suppose C language only compiler, Python only interpreter, HTML only interpreter. Java is a special case. Java depends on both compiler as well interpreter. Okay. Yes, Java depends on, yes, Java, it depends on Java, depends on, yes, both, depends on both interpreter as well compiler, interpreter as well as compiler. Yes, Java, there are two things here, interpreter as well compiler. So Java program execution by the interpreter. Okay. Next, one more here. See, any language program execution, any language program execution Any language program execution by the interpreter, by the interpreter, by the interpreter. Yes, the program, any language program. See, any language program execution by the interpreter, execution by the interpreter don't have exe file, don't have exe file. Okay. Yes, any language. Yes, that program, if it is executing by the interpreter, don't have exe file. If program executing by the interpreter don't have exe. If program executing by the interpreter don't have exe file. Okay, so program executing by the interpreter don't have exe file. Don't. Okay. Yes. Now question for you guys. Question. Yes. Can we create exe file in Java? Yes. Can we create exe file in Java? Yes. What's your answer? Tell me. What do you observe now? Yes. As per our last explanation. Yes. What you observed? Yes. From our last explanation. From my last explanation, what do you observed? Can we create exe file? Is there
No,
an exe? Yes. Have you observed any exe file? See, first notepad test.java, Java C sample.java. Yes, Java sample, right? So notepad sample.java, Java C sample. So you can sample.java, sample.class. Only sample.java, sample.class, but don't get sample.class, right? Dot class is not observed anywhere here. No dot class. Sorry, no dot exe. So only dot Java, dot class. Dot Java, dot class. No dot exe. Okay, dot exe nowhere observed, right? Means it won't generate exe file. Means here Java don't have exe file concept here. Can we create exe file in Java? No. Okay, no. No. Yeah, there is no. See, there is no exe file concept. There is no. Yeah, there is no exe file concept in Java. Concept in Java. There is no exe file concept in Java here. Okay. There is no exe file concept in Java. Okay. See, if exe file come to picture, there is platform dependent. Java is independent platform because Java program files are not exe files. That independent platform tomorrow we'll discuss. Tomorrow I'll explain about independent platform. Okay. How Java made us independent platform. Tomorrow topic. Tomorrow we'll discuss that here. Okay. There is no concept of exe file in Java. See, in Java, yes, everything is dot class file. Yes, finally generating one dot class file, that dot class will execute here. So everything in Java, everything is an yes, everything is a dot class file. Everything is dot class file. Okay. Yes, in Java, everything is a dot class file. In Java, everything is a dot class file. Java, everything is dot class file. Okay. Yes, everything dot class. But here dot class is not exe file. Dot class is not an exe file. Dot class is not an exe file here. Dot class is not an exe file. When dot class is different, exe file is different here. Dot class is not an exe file. See, exe file is a binary code file. 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 See, dot class file. Dot class file is a byte code file. Dot class file is a byte code file. Okay. See, exe file is a binary code file. Exe file is a binary code file, and it's a system understandable language. It's a system understandable language. It's a system understandable language. Exe file is a binary code file. It's a system understandable language. What is dot class? Dot class file is a byte code file, and it's a JVM understandable language. Yes, it is JVM, Java Virtual Machine. A JVM understandable language. JVM understandable language. Okay, JVM understandable language. Next, one more thing. Yes, exe file. Yes, is a OS dependent. Exe file is OS dependent here. OS dependent. So OS dependent here. OS dependent. Exe file is a OS dependent. So why exe file is OS dependent? Tomorrow we'll discuss. Tomorrow topic about exe file, dot class file. Next, independent platform. Yes, tomorrow very important. Very, very important topic here. Very interesting topic also. Tomorrow topic is very interesting. Yes, independent of platform. Independent of platform. The topic will be discussing tomorrow. Yes, exe file is a OS dependent. Exe file is a OS dependent. Yes, dot class file. Dot class. See, dot class file. Yes, is an yes. Yes, OS independent here. Independent of OS. So dot class file is a independent of OS. Okay. Same thing explain document. I'll just to follow the document here. See the document. Today's class document. Interpreter versus compiler, the differences. All the differences clearly prepared. All the differences clearly prepared. Interpreter compiler, all the differences. Okay. Yes. Java depends on both the compiler as well interpreter. Okay. Java errors checking by the compiler. If no errors, then Java compile generates dot class file. Dot class file is a bytecode file. See Java runtime by the interpreter. Program execution by the interpreter. Okay. Source code given to Java compiler. Generating bytecode file is given to interpreter. Finally generating output. See source code to bytecode to binary code, processor then output, right? The sequence of steps here. Source code to bytecode by the Java compiler, first step. Second part, bytecode to binary code by interpreter. So this part is a compiler and second part by the interpreter, that's it here. So Java depending on both the compiler as well, interpreter both here. Okay, Java runtime is interpreter based. See, any language runtime interpreter based no exe file. Same that point we discussed already. Okay, any language runtime is program execution by the interpreter don't have exe file. Any language program execution by the interpreter don't have exe file. Okay, any language runtime is interpreter no exe file. Yes, can we create exe file in Java here? No. There is no concept of exe file in Java here. Everything is a yes dot class file. Everything is dot class. There is no concept of exe files in Java here. Okay, everything is a dot class file. See, dot class is not exe file. Yes, exe file is a binary code file. It's a processor understandable language. Dot class file is a bytecode file. Bytecode file, it's a JVM understandable language. Dot class is a bytecode file. Bytecode, it's a JVM understandable. Exe file is OS dependent. A dot class file is independent of OS here. Yes, this OS dependent, independent is tomorrow topic. Tomorrow topic we'll discuss. Okay. Now, what you understand finally today here, interpreter compiler differences. Main difference exe file. Compiler generates exe file, interpreter does not generate. So finally conclusion, interpreter based language don't have exe file. Interpreter based language don't have exe file. So what is next? What do you learn next here about Java? Java depends on Java depends on both compiler as well interpreter. Java depends on both compiler as well interpreter. Okay. Yes. In Java, this is a bytecode. Bytecode introduced here. So why this bytecode introduced? To make the Java as independent platform. Bytecode introduced to make the Java as independent platform. Where that point mentioned here. 1 second. Just to make Java program as independent platform, independent of platform. Just bytecode was introduced. Okay. Yes, bytecode. See, bytecode was introduced here to make Java as independent platform. Yes. So why this bytecode here? Bytecode was introduced to make the Java as independent platform. Okay, Java depends on both compiler interpreter. Yes, Java runtime is interpreter based. Okay. Yes. Can you create exe file in Java here? No. Okay, there is no concept of exe file. That's it here. Okay. So in Java, Java, yes, next one more point is what Java depends on compiler as well interpreter. That's it here. In Java, error checking by the compiler, program execution by the interpreter. Error checking by the compiler, interpreter executing, right? Next, there is no exe file concept in Java. That's it. So this is about Java introduction. Okay. Yes, next topic is about Java features. How Java made us independent platform. Yeah, tomorrow topic is very interesting. Don't miss tomorrow topic here. Okay. Yes, even from the beginning, don't miss. Okay. Please try to join sharply. Okay, at 9:30. Yes. Yes, please try to join at 9:30. Yes, some guys are coming late. Please try to join at 9:30. Okay. Yeah. That's all for today. Still any doubt? Any doubts are there? Any doubts? Yes. So this is WhatsApp number. Share our details to WhatsApp number. I'll add to group. Take this number. Take this number. Yes. I'll add to group. Take it. I'll add to group. Yes. Everything communication is going in the group here. Okay. Yeah. Today I'll give the drive access. Today afternoon. Today by the afternoon I'll give the drive access. Okay. You can see everything in the drive here. You can see all in the drive. That's all. That's all for today. Okay. Yeah, that's all for today.
All right, sure. Thank you. Good night. Good day.
Yeah, that's all. Yeah. Have a great day. See you tomorrow.